What's up, my statisticians? This is Professor Sampson of PS I Love Math, back with another statistical banger. And so I just want to invite you to my channel, so we're going to jump into it. Are my glasses crooked or is my head crooked? Well, let's switch. Let's put on the Versace's. Let's do that. Let's see. Somebody crooked. I don't know. I think my head is crooked. Anyway, you ain't come here to hear about my head. You came here to hear about some math. So today we're going to be learning about comparing two population means when the sigma is known and we have independent samples. That's what we're doing today. But real quick, don't forget to like, please comment and tell me what other videos you want so I can pop them up there. And definitely subscribe to the channel. Subscribe. Don't forget, on that way to 1,000 subscribers. I only got like 200. I ain't even got 200 yet. I'll be honest. I got like 175. So help us out. Anyway, let's get started with our video. And of course, as usual, I'm going to share my screen. So let's get ready. All right. So today's problem, if I can find it, is here, right? A sports news station wanted to know whether people who live in the North or the South are bigger sports fans. For a study, 121 randomly selected Southerners were surveyed and found to watch a mean of 4.1 hours of sports per week. In the North, 137 randomly selected people were surveyed and found to watch a mean of 3.9 hours of sports per week. Find and interpret a 99% confidence interval for the true difference between the mean populations of hours of sports watch per week for the two regions if the South has a population standard deviation of 1.8 hours per week and the North has a population standard deviation of 1.9 hours per week. Woo! Now that's a lot of reading right there, okay? A whole lot of nothing. So let's see what we can get out of it. Remember, this is not an English class. This is a math class, fortunately, or unfortunately, depending on how you want to look at it. So what I usually do is I'm going to pull out all the relevant numbers on what's going on. So we're going to start with that first number up here, 121 randomly selected Southerners, okay? So that's going to be, since this is my first number, I'm going to start that with N1. But what I'm going to do is I like to name mine so I know who I'm talking about. So I just put Southerners right there. No reason other than that's what I like to do. So we got N equals 121. And as we continue to read, we're surveyed and found they watch 4.1 hours of sports per week. And so who were they? Of course, they were the 121 people surveyed. So that is a mean. Remember, mean has two letters, X bar or sigma. All right. X bar or mu. I didn't say that. All right. So which one is it? X bar is sample, mu is population. Well, it's obviously 4.1 is of that sample. So that's going to be X bar. Then we move down to the Northerners, which I am actually a part of normally. I just live in Maryland now. All right, the North we have N equals 137, right? And then they spent 3.9. Their mean of that 137 was 3.9 watch hours. Okay, and we know we're looking for a 99% confidence level, but by now you should know that that means alpha is 0.01. Okay, and then we go to the bottom, all right, and they tell you the population standard deviation. The South has a population standard deviation of 1.8. So they're giving you the population standard deviation, right? Which is what? All right. The standard deviation has two letters, S or sigma. And this time, this is sigma for the South. So sigma is equal to 1.8. And then sigma for the North, the population standard deviation. So you know they're going to tell you if it's the population standard deviation. So we have our information right there. So what do we need for a confidence interval, for a correct confidence interval? Well, we need a margin of error, right? So a correct confidence interval is written like this, if you want to take a look at it, for a population for 2. So I do have should have my formula sheet down here. Let's see if it's on it. Yep. Confidence interval for the difference between 2 means, independent samples. Now this right here is the sample, but we know the only difference between the sample, this is going to be the formula in a minute, but the only difference between a sample and a population is that here you have sigma, or here and here you would have z. Okay, so we'll fix that formula in a minute, but just so you know, in case your instructor might have you do that. So we have x bar 1, and I should have named this 1, 1, and 1, right? And this is 2, 2, and 2. But the base formula is x bar 1 minus x bar 2, right? Minus E is between mu1 minus mu2, right? The population mean. That's what we're trying to approximate. Right? And then plus E. Plus E or M, depending on depending on your book, it might be E or M. Either way, it's the margin of error, which you should already be familiar with, because we're doing 2 samples. You should be used to it by doing 1 sample, okay? So let's get started in the things we need. Well, we already have the beginning. We have our x bar 1 and x bar 2, so let's plug that in. Probably should fast forward this. Okay, so we'll take care of that, and then we'll do 4.1 minus 3.9. Right? Make sure that you just pull out your calculator, even if you know it. Always double check and make sure you're right. So right now you have 0.2. Okay, so now we need to work on E. What's the formula for E? Or M, margin of error. The formula in the text that I'm using, call it margin of error. Well, the margin of error is actually the Z alpha over 2. Why is it Z alpha as opposed to T alpha? Because we know the population standard deviation, so everything is going to have to do with that. And then sigma squared 1 over N1 plus sigma squared 2 over N2. Now, the only thing you need to do for me is you need to check with your instructors, is you need to plug in for me all of the numbers, and then you can use your calculator. Now we need alpha over 2, right? Because we're looking for a confidence interval. So we need alpha over 2. So our alpha was 0.01, and we're going to divide that by 2. So alpha over 2, I'm going to put over here. That's equal to 0.005. So we need to find Z alpha over 2 in a minute, but we can plug in all the rest of our numbers here for sigma 1 and sigma 2. Okay, and the last thing you need now is Z alpha over 2. Okay, so let's look up Z alpha over 2. Actually, let's take the Z alpha over 2 because it's no longer Z alpha over 2. We're looking for Z of alpha over 2, we know is 0.005. Okay, so let's go to our Z chart, which you know I have here. All right, so let's back this out a little bit because I have it zoomed in. Let's zoom out. I feel like this video is boring. Ugh. All right, I feel for you. Because if I'm bored, I know you bored. I don't know, I'm just not myself today, but I wanted to get this video out for you by hook or crook, right? Sometimes you don't feel like it, but you do it anyway, right? 0.005. So I'm looking for 0.005 on this chart here. I got 0.0047, 48, 49. Now, as you notice, I don't have 0.005. 0.005 would fall in between these two numbers. And remember, this is the only time a z-score will have 3 digits if you're in my class. You might want to check with your instructor if you're watching this off of YouTube. But between these two numbers is 0.005. So we need to take the average or the mean of those two numbers. So that's 2.57 and 2.58. So we're going to take the average of those. So really quickly, take 2.57 plus 2.58 and then divided by 2. And your z alpha over 2 is 2.575, okay? See where I got those numbers from, 5.7 and 5.8? All right, so 2.575 is our z alpha over 2. I won't accept anything else. You may need to talk to your instructor if I'm not your instructor. 2.575, all right? And then we have all of our numbers already plugged in here. So once we do that, now we can go to the calculator. Once your instructor sees that you know what the number should be and you could put it in the calculator, at this point it's not necessary to go through the other ropes. So let's check it out. So where do we go? We go to stat and we go to test. All right, and what kind of test are we doing? Well, because we have the standard deviation of the population is known, we're going to use a z-test, and we're looking for a z2 sample interval. All right, not just a z interval. So 2 sample interval, which is number 9. Now, do we have data or do we have stat? Well, we don't have data. Data would be something that we put in our calculator. So we're going to go to stat. And now we need to put in all of these statistics. Okay, we're just going to fill them all in. Okay, so I put all the numbers in. I didn't want to make the video longer than it should be by you watching me put in all the numbers. But here are all the numbers from our information that we got from our problem. So once you put in all those numbers, the only thing that I wanted you to see was the confidence level. Make sure you put it in decimal form, and it's 0.99. That's the confidence level. All right, then we hit calculate and we see what we have. Okay, so the calculator spit out something to you. So the rounding rule, what are we talking about? Well, we're talking about mean. And what's the rounding rule for mean? See, talking about mean here. So what's the rounding rule for mean? The rounding rule for mean is one more decimal than is listed in your data, which we don't have data, or the numbers are already listed. So we're already given a rounding rule. We're already given what X bar should be rounded to, okay? We're already given that because we're just adding it to this 0.2. So our answer is going to be 1 decimal place. So let's take a look at what our answer should be in this 1 decimal place. Looks like negative 0.4. And you need to write it that way. Do not write it like the calculator gives you in comma. Negative, like 0.4 is less than mu1 minus mu2 is less than 0.8, right? 0.8, 0.8. So that's the first part. So the question asked you for the confidence intervals. Find and interpret the 99% confidence interval. All right. So what does that mean? How are we going to interpret it? Now, the interpretation for this is going to be similar to hypothesis testing, right? So we're going to interpret, right? So our interpretation is going to be what? We are what, 99% confident, right, that the mean number of hours, you need to write the whole thing out, of sports watched per week by Southerners is between 0.4. Now you get zero, I'm gonna put 0.4 hours less than, right? So I can say that because I'm comparing it, but 0.4 hours, if I can write it right, and 0.8 hours greater than the mean number, right, of hours of sports watched, right, by Northerners. Right? So that's the beginning, right? This is our interpretation, right? This is our interpretation. We are 99% confident, because that's our confidence interval, that the mean number of hours of sports watch per week by Southerners is between 0.04 hours less than and 0.08 greater than the mean hours, the mean number of sports watched by Northerners, right? Because that's what we're talking about. That's what we're comparing, Southerners to Northerners, okay? Southerners to Northerners. So that's why the order is so important. All right, and what else does this mean? Right? So the thing about the interpretation, this data includes zero, right? This interval includes zero, right? So the data does not provide evidence that the two population means are unequal, all right? Because they could be equal. How do we know they could be equal? We know that they could be equal because what? Right? We know that they could be equal because zero's in the middle, because zero is in the middle. So it's possible that they could be equal. So since the interval contains zero, those things can be equal. So we don't have any evidence that they're necessarily unequal. Right? So that's what they mean when they ask you about zero in the confidence interval. Remember, zero means that they're equal. If zero is included, it means that there's a possibility that it could be zero. Then that means that there's a possibility that there's no difference between how much Southerners and Northerners watch TV. Okay, there could be no difference. So it could be that they're the same. Had we not had zero, then we would discuss that they definitely weren't the same, because we're at a 99% confidence level. Okay, so that takes care of that one. Ooh, that one felt just so not, I wasn't feeling it. But you know what? I could have redone it and found me another one and been all happy and excited or whatever. But the thing is, you're not always excited about every math problem. You're not always excited about math, but you get it done. So that's the answer right there. Thank you for watching, and don't forget to subscribe to the channel up here somewhere. Just click the subscribe button so that I know that you are feeling these, so I can put out more statistical bangers. Thank you. This is Professor Sampson from PS I Love Math.